Got it.
All right, so it should look something like what I've got here. It should have sort of a U shape to it.
Yeah.
Which is different than the previous one. The previous one was a line, so you could just connect them. It should have some curvature to it. You know, you've mentioned you've got some artistic abilities. Make it look nice, roughly nice and smooth, not connected straight lines. All right. Any questions on that before we move on to the next ones?
No.
Okay. All right. So starting with number 3 here, the data sets, they're asking you if they are linear, quadratic, or exponential. And to do this, you're going to find what's called the first difference and then the second difference if needed. Okay, and if it's not clear what I mean by that, you take the next y value and subtract the previous y value. That's going to be what's called the first difference here. So you're taking that 6 minus 3, which is equal to 3. And then you take the next y value, 12, and subtract 6, which is 6. And then 24 minus 12, which is 12, okay? And so there's a little more here. The first difference, if the first difference is the same, it's linear, which is not the case here. Like if all these numbers were the same, it would be considered linear. For the second difference, you do the same thing, but you use these new values. So this time it's 6 minus 3, which is 3, 12 minus 6, which is 6. If the second difference is the same, it's quadratic. So I think you can see here that the first difference is not the same and the second difference is also not the same.
Yeah.
Okay, that means it's something else. All right, so this is maybe a bad one to start with. The other thing you can do is look at how to get from the y values using multiplication or division. Basically, what would you multiply 3 by to get to 6?
2.
2. And then it's like, well, does that work? Can you multiply 6 by 2 to get to 12?
Yeah.
And then from 12 to 24?
Yeah.
So when it's the same, when this is the same, this is exponential. But it could also be either multiplication or division.
Okay. Makes sense.
Okay. I should have looked ahead here. We're going to do 5 first. Yes, we're going to do 5. No, sorry, we're going to do 4 next. Sorry. All right, so let's do this first difference thing again. Okay, I'm going to make a little more room here for it. So the first difference is you take the next value and subtract the previous value, and it's always the y. So it's minus 8 minus a minus 10.
Yeah.
So what would that be? What is minus 8 minus a minus 10?
2.
It is 2. Then we go minus 6 minus a minus 8. What does that become?
2.
2. Minus 4 minus a minus 6 is also 2. Since the first difference is always the same, this one is linear. Is that okay?
Yeah,
All right. Did you see it? Was this explained differently in class?
sort of. I didn't see the like the first and the second
Difference.
yeah, difference.
Yeah. All right. Well, let's do it again here. I think you'll like it. I mean, but I don't think it's overly complicated subtracting. So I want you to find the first difference for me for these three. Do you have an answer for me?
And I'm still trying to figure out the. Or wait, did you ask for the?
Yeah, just the first difference. Do you have that?
Okay. Yeah, 4
Okay. Keep going.
and 6 and 8.
Good. All right. So now the second difference, you use those new numbers, so you can only get two of them now. But what would the second difference be?
Two.
2. Since they are the same, since the second difference is the same, this is quadratic. There are other ways to do it. This is just the way I'm showing you for today because I found it works for most students, but if you don't like it, there is another approach I can show you as well.
This is pretty comprehensible. Is
Good.
what is the other way?
You can sketch a graph and kind of look for a pattern that way. That's kind of what they were having you do in questions 1 and 2. And you can make sort of a rough sketch. It doesn't have to be like perfect, but you'll get a feel pretty quickly whether it's linear or not. All right, so the first difference here would be my way of going on this one. Your first difference is always the kind of the next one, like in this case, the 0.9 minus the 0.45, then the 1.35 minus the 0.9. Could you calculate the first difference for us, please?
Sure. .45.
Yes, they're all 0.45. And so does that make this, what kind of model is this then? If their first difference is all the same?
Be linear.
Yes. So if you were to graph this, and you don't have to graph it very nicely, but it's okay. There's 1, there's 0.45, there's 2, there's 0.9, 3, 1.35, and you start noticing it looks pretty linear.
Yeah.
Okay, so that's why I like this approach. The one reason that you might like I like the difference approach because if it's not linear and it's not quadratic, then it's usually the other one. It's kind of the not true situation here. So again, I'd like you to calculate the first difference for us, please.
All right. One.
Okay, how about for the next one? 7.2 minus 6.
1.2.
Okay. And then the next one, 8.64 minus 7.2.
1.44.
Yes. Now, these are obviously not the same, so we'll go to the second difference. We only can do 2 of those here. Can you calculate the 2 differences? What's the first one here? 1.2 and subtracting 1.
Oh, 0.2.
0.2, good. And then for the second difference, you're always looking at the previous line. You're not looking at anything else. This one would be the 1.44 minus the 1.2.
So 1.22, or no, just 0.22.
0.24. 0.24.
Oh,
Okay, and these are not the same. So this means it's not linear and not quadratic. Now, since it's drop down, you probably can figure out which one it is. It's exponential. If it's exponential, that means there's a multiplier. Like you can multiply to go from 5 to 6, 6 to 7, 0.2, 7.2 to 8.64. And unlike the previous problem, this one may not be as obvious. So to figure out that multiplier, it's called R, by the way. You take the next number and divide it by the previous number. The next number divided by the previous number. The next number divided by the previous number. Now, do you have a calculator handy for us today? Available?
yeah,
Okay, will you quickly calculate each of these for me?
sure. It's all 1.2.
They're all the same. They're all 1.2. So for an exponential, the multiplier or the division has to be all the same. So in this one, it would be an exponential model. And sometimes you get that like by, okay, it isn't that one, it isn't that one. Must be that one. Questions, thoughts on that?
It's all pretty good.
All right, now I don't see 8 and 9. Maybe you meant to send those, but I don't have 8 and 9. I got 10. Could you just double check that we're not missing some today?
Yeah, it was a typo.
Okay,
There's no 8 and 9.
got it. All right, so let's go to 10. I believe 10 will be really similar to what we've been doing here. So the thing that you don't want to do is you don't really want to focus on the X value at all. You can even get rid of it. You want to just focus on the Y value. And so I would do that first difference. Excuse me. So I would find the first difference between 9 and 0, 0 and -7, -7 and -12. So go ahead and calculate those and let me know what you come up with.
-9, -7, and -5.
Okay, so it's not linear, but maybe it's a quadratic. So now take the next differences.
It's both +2.
Yeah, so because the second difference is the same, we know that it is quadratic. All right, so go ahead and try number 11 on your own. I recommend using the same approach, and let me know what you come up with for this one, please.
It's all 4.
Okay, so what does that mean? The 4 is the first difference?
Uh, That means that it's linear.
Yes, exactly. It actually doesn't matter what the number is, as long as the first difference is the same, it is linear. All right. So we'll look at number 12 together here. The first difference is 2. 6 minus 4 is 2. 9 minus 6 is 3. And 13.5 minus 9 is 4.5. I think you can pretty quickly see that these are not the same.
Yeah.
Okay. Now we do the same thing though. We're like, all right, well, let's just be optimistic here. 3 minus 2 is 1. 4.5 minus 3 is 1.5. So this one, unfortunately, is not linear. It's not quadratic. It is exponential. So when it's exponential, and we did this in an earlier problem, you really should figure out what what's called the R value is. It's the ratio, and it's the next divided by the previous. So you really don't care at all about the X values. So, but it's 6/4 It's 9 over 6. It's 13.5 over 9. And then you hope that they're all the same. Do you want to try calculating that for us and seeing if they're all the same?
Sure. Yeah, they are.
Yeah.
1.5.
Yes. 3 halves or 1.5. And that's the multiplier. That's like how you go from 4 to 6. You multiply by 1.5. 6 times 1.5 is 9. 9 times 1.5 is 13.5. So it's really a progression. It's like, all right, it's linear, yes or no, quadratic, yes or no, and then probably it's exponential. There are other things, but this is kind of the types of problems you're looking at for today. All right, why don't you try 13 on your own? Ask me some questions if you have any along the way, but let me know. Let me know what you come up with.
All right. Got quadratic.
Okay, so first difference to second difference. So first difference would be 8, 24, and 40. Is that right?
Yeah.
And then second difference is 16 and 16. You got it. All right, good job on that. Hopefully that's a simple enough algorithm recipe that you can reproduce here on your own. Do you have some other things you'd like us to work on today? Something else you can send over?
Yeah. I think I have something else. Okay, I sent over some like completing the square stuff.
Oh boy, my favorite.
The best.
Yes. Okay, so we'll take a look at those. I thought maybe you're transitioning out of that quadratic stuff, like typically the end of the course is like linear versus exponential, and you're totally done with quadratics, but apparently not.
Yeah.
I'm stalling here until the email comes in. There it is. All right. More.
A lot of the kids did absolutely awful on it.
And how did you do?
Pretty good since I knew what I was doing.
Got it. Yeah, that's good to hear. This some of these might be completing the square, but like this first one is not, in my opinion. I mean, it could be done by completing the square. Does it say thou shalt complete the square, or does it just say to solve by any method?
It says to solve, but some of them look like the like completing the square thing.
Yeah, and some of them are, if some of them are for sure, or they line up well. This one is what I call that a equals 1, where you're looking for multiply to minus 35, but add to -2. So you're looking for two numbers that multiply to 35-ish, -35, one's positive, one's negative, add to 2. That means they're 2 apart. The two numbers that you have here are 2 apart. So go ahead and see if you can figure that out, please.
Get 5 and -7.
Yes. So that becomes, there's this kind of this intermediate step here, x minus 5, x plus 7. So you remember what we do from here?
Gotta have the two things in parentheses equal to 0.
Yes,
Gotta do them both.
exactly.
So it's x equals 5 and then x equals -7.
Very good. All right, let's look at, see if I can find another one kind of like this. All right, so let's actually look at 11 next.
All right.
So 11 is in the wrong form. You really want it to equal 0. How can you make this equal to 0?
Gotta move the 4. So -4 on both sides.
Very good. So now you're looking for two numbers that multiply to -4, but add to +3.
-1 and 4.
Yes, so this becomes x minus 1, x plus 4 equals 0.
And that becomes x equals 1 and x equals -4.
Good. All right, let's have you do 9 on your own here. 9 is like the ones we've been doing. Let me know if you need any guidance on this one.
I got x minus 10 and x minus 10.
So the two numbers, you've got the right numbers, but it's x
Or wait,
plus. Yeah, it's
yeah.
maybe you meant the final answer. I'm not sure.
Yeah.
So yeah,
It was half and half, the final answer, and then the answer.
yes. Good job though. Good job on that one. All right. So let's do a completing the square problem here. Because you mentioned it, might as well tackle one of those. This one I feel like is a good completing the square type question. The reason is it does not work out the way the other ones had worked out. You can always use quadratic formula though, but let's do completing the square because you probably don't see enough practice with that, and you will see it again at some point in the future. So first thing is to move that 10 to the other side of the equation. And then your instructor had this really cool idea to put these boxes here, which I think is a great idea. You're going to fill those boxes in with a number based on the completing the square part. So we do that by looking at this middle number here, this 14. Do you remember what we do for that?
Divide it by 2 and then
Yes. And then
square it.
And to be fair, you do it to both here. I think I overheard your dad say that you're a twin. Is that right?
Yeah.
Yeah. So it's like if your sister gets, if 49 is something, you get 49 is something. I think that's the way it works. Maybe.
Maybe.
Maybe, right? Sometimes. Depends what it is. So the sharing thing here, it's got to be the same number. Subtract 10, add 49, that becomes positive 39 on the right. Okay, now the last thing you would do from this position is foil this on the left. Like if you foil it and you go backwards, you want to now undo the square root. So how do you undo a square? I'm sorry, how do you undo a square? I just said it.
You gotta square root both sides.
Yes. And it's plus or minus the square root of 39. X plus 7 squared on the left is x plus 7. All right, now the square root of 39 cannot be reduced. There's no factorization of it either. I'm just kind of helping out by saying that so that the answer is going to have that in there. And then you subtract 7 from both sides. I recommend putting it in the front, minus 7 plus or minus the square root of 39, like that.
All right.
All right, any questions on that?
No.
Okay. I guess we can look at 13. Really quickly do this one. Actually got plenty, we got some time. We started late, we'll go a little late here. So this we'll do as a completing the square again, but this time we're going to first move the 6x left because we really want the two x terms to be on the left side. This is all just the setup or the rewrite, if you will. right? So tell me, once you get caught up here, tell me what goes in parentheses down below here.
X plus 9.
So it's half of the 6, half of the 6,
Oh wait, yeah.
and it's negative this time. So the 9 actually is what goes into here.
Oh, okay. As a little head.
So it is plus 9, plus 9. What is the next thing to do when we're at this point?
Square root both sides.
Good. Is the square root of 19 a known value?
No.
So just the square root of 19, unfortunately. Can't do anything with it. X minus 3 goes plus or minus square root of 19. Add 3 to both sides. So x equals 3 plus or minus the square root of 19. Is this assignment due tomorrow? What we've been working on here, this last few problems?
Yeah.
It is, okay. So let me try to give you some guidance here. I don't think we did 10. Is that correct? We did not do 10.
No.
This is completing the square problem. Fourteen, when you bring it back left, x squared minus 10x equals 25. This becomes, wow, that's really bad. Plus 25 equals 0. This is an a equals 1 problem. $15 will be a completing the square problem. $16 is a completing the square problem, although it does not work out nicely, meaning it's no real solution. And then 17 is also a completing the square problem. All right. We do unfortunately have to stop here. I would just make your best effort on this and then submit it.